All right, we're going to continue talking about building functions from functions. And the first thing we're going to talk about is decomposing functions. To decompose functions, you determine the functions in the composite function. So for each function h, find functions f and g such that h of x equals f of g of x. So they're saying that here's your h of x function. It's really simple. All you do is you look to see what's inside parentheses. In this case, it's x plus 1. Okay? This is a quadratic function. Okay? So what you do is, the function h has a quadratic function in it, ax squared plus bx plus c, where, if you look, a would be 1, b would be -3, and c would be 4. So what you do is, you determine what x is being replaced with. Normally these are just x's. But the quantity that x is being replaced with is x plus 1, right? So then you're going to say, so g of x has to be whatever's inside parentheses. This guy right here is whatever is in parentheses in your function, pretty much. Okay? Then check to see if so if g of x is this, then f of x, if I plug f into, if this was f and I plug g into f, everywhere there's an x, I change it to x plus 1, it looks the same. So this is equal to h of x, so we found f and g, the f and g functions. So there's your f of x, and there's your g of x. Alright, so here's what I do to make it simpler. Basically, you find the grouping symbols, okay? And this is the grouping symbol. It's a square root function. And so the inside is the most innermost, the g of x, is going to equal what's incorporated inside that grouping thing. So my g of x is whatever's inside. That's going to be x cubed plus 1. Your bigger function, your f function, take this out and replace it with x. So there's my f function. Alright, and if I did f of g of x, I would take g and plug it into the f function. So it works. Okay? Alright, you try this one. Hit pause, come back when you're ready. And this one wasn't really fair to me because I didn't do any fractionals. Basically, this is you got to think of your mother functions, your parent functions. Remember our reciprocal functions, 1 over x? Whenever I see fractions, I automatically think of a reciprocal function. Okay, it's just that instead of x on the bottom, they put x squared minus 5, which means your f function is the reciprocal function, and your g function is whatever they took x out and replaced it with, which they replaced it with x squared minus 5. Okay? Okay, try this one. Hit pause. Come back when you're ready. Again, the parent function here, I see a square root, so my parent function, my mother function, is the square root function, which is my big function. My f of x is the square root of, it's the square root function. Now, instead of x, they put this garbage in there, which is your g of x. Your g of x is whatever they replaced x with, which is 52x squared plus 15. Okay? Alright, so how do you decompose a function? Well, you find what's ever in parentheses or replacing just plain x is your g function, and basically the mother function of that function is your f function. Okay, so put that into a complete sentence, Alright. So this one says, in the medical procedure known as angioplasty, doctors insert a catheter into a heart vein through a large peripheral vein and inflate a small spherical balloon on the tip of the catheter. Suppose the balloon is inflated at a constant rate of 44 cubic millimeters per second. A, find the volume after t seconds. Well, if this thing is inflating at 44 cubic milliliters per second, okay, then your volume is getting bigger by 44 each second, okay? So my volume after t seconds is going to be 44 times how many ever seconds there are. Okay? It says when the volume is v, what is the radius r? This, they're stepping you through it. I don't do this step. They're just saying because you're trying to find r, they want you to manipulate this equation until you get r alone. So they said they divided by 4/3 pi and got this. Then they took the cube root and they said that the radius is the cube root of 3 volumes over 4 pi. Okay? You don't really need to do that. Alright? If you just take this formula and you say write an equation that, well, I guess I can't because it's saying write an equation that gives the radius as a function of time. What is the radius after 5 seconds? Well, what they're telling you is my r is going to be the cube root of 3 times, I know my volume. My volume is 44t over 4 pi. So if I if I plug in 5 for my time, I get r equals the cube root of 3 times 44 times 5 over 4 pi. And if you type that in a calculator, you get approximately 3.74, what is that, millimeters. Okay. Alright, T. Let's look at another one kind of similar to that. It says a high altitude spherical weather balloon expands as it rises due to the drop in atmospheric pressure. Suppose that the radius r increases at the rate of 0.03 inches per second and that r equals 48 inches at time equals 0. Determine an equation that models the volume v of the balloon at time t and find the volume when t equals 300 seconds. Well, what it says is your r is increasing at 0.03 inches per second. But it's not just that, because it's telling me that it started at a volume of already 48. So it's 48 plus 0.03x. My volume equation is 4/3 pi r cubed. You just need to memorize that one. I'm not going to do like the last one. They went through all the trouble to get r alone and all of that stuff. I'm not going to bother doing that. It's asking me, my radius, remember, is this. So if I just replace r with that, I'm going to have v equals 4/3 pi 48 plus 0.03x cubed. Okay, so then that's my equation for volume. Then it says figure it out at 300 seconds. So they're telling me to change x to 300. So my volume is going to be 4/3 pi 48 plus 0.03 times 300 cubed. If you type this in, I've simplified it a little bit. Inside gave me 57. And then I typed it in and you get 775,734.62 inches cubed. Okay, which is really big, but it's a weather balloon. They are really big. Okay. Alright, you try this one, hit pause, come back when you're ready. Alright, a high altitude spherical weather balloon expands as it rises due to the drop in atmospheric pressure. Suppose that the radius r increases at a rate of 0.07 inches per second and that it started at 36 at time 0. Determine the equation that models the volume, which is 4/3 pi r cubed. So I just replace my r with that. So it's going to be 4/3 pi times 36 plus 0.07 x cubed. And then they want me to figure out at 400 seconds. So they're telling me to change x to 400. And if you simplify that, I get 4/3 pi. This mess all comes out to 64. Type that in and I get 1,098,066.219. And they said round to the nearest hundred. So there's my volume. And There's my equation. The only thing they did, guys, is instead of writing 4/3 right here, they just put all 4 pi 36 plus 0.07 x t cubed, and they put the 3 on the bottom instead of over there. This is not wrong. We're fine. Okay. Alright, so now we've got something interesting. We've got a satellite camera takes a rectangle-shaped picture. The smallest region that can be photographed is a 5 by 7 rectangle. As the camera zooms out, the length L and W of the rectangle increase at a rate of 2 kilometers per second. How long does it take for the area A to be at least 5 times its original size? So what they're doing, guys, is they're starting off with this rectangle that's 5 by 7. And they're zooming out, and they're zooming out, and they're zooming out, and this thing keeps getting bigger and bigger and bigger. And they want to know how long, and it keeps getting bigger at a rate of 2 kilometers per second. They want to know how long is it going to be for this to get to be 5 times its original size. Okay, so we need a couple of things. First of all, we need the initial area. We know area of a rectangle is base times height. The initial area of my first rectangle is going to be 5 times 7, which is 35 kilometers squared. Okay, there's my initial area. We want, now my new length is not 5 anymore because it's going to be getting bigger by 2 kilometers per second. And my new width isn't 7 anymore because it's going to keep increasing by 2 kilometers per second. So now, don't we know that the area of my new rectangle is going to be my new length times my new width? We do. But didn't it say something about they wanted to know how long it would take for that area to get to be 5 times its original size? So the original size was 35. 5 times that is 175. So I want to know when this area right here becomes 175. So we're going to do this graphically. You could do it algebraically. To do it algebraically, you would FOIL this out, get 175 over, make it equal to 0, and do quadratic formula, which is absolutely possible, all right, and acceptable. But I'm just going to show you graphically. Okay, whenever you have, and use this like ACT, SAT, all the time, whenever you have an equation and you're trying to solve it, you can always type one side in for y1 and the other side in for y2 and then calculate the intersection because that's when they will be equal. So that's what we're going to do. So you're going to go to y equals and you're going to type in this for y1 and 175 for y2. Then you're going to set your window. I kept my x's going from -10 to 10. My y's -5. I went all the way up to 200. Why did I pick 200? Well, I'm trying to get to 175, so I went a little bit bigger. And because I'm going such a long ways, I changed my scale from counting by ones to counting by 20s. So now, when I hit graph, you can see this function is a parabola, because if you multiply it out, you get a 4t squared, which there's my parabola. Okay, and then there's my 175 line. There's 2 intersection points here and here. This one is going to be at a negative x value, which means negative time, which in the context of this problem doesn't make any sense. It's mathematically a solution, but in this context, we throw it out because a negative time makes no sense. So I want to calculate this intersection point. So you're going to go to calculate, and this time I want to choose intersect, and it's going to ask you for first curve, second curve. First curve, it's pointing its cursor on the parabola, which is fine. Just hit enter. It should jump up to somewhere on the line. Just hit enter for second curve. And then it wants you to guess. Just hit enter again. And it'll tell you the intersection is when x equals 3.63. You get an area of 175. So what it means is, how long is it going to take? It's going to take approximately 3.63 seconds to enlarge that photograph. Okay. Alright. So you try one, hit pause, come back when you're ready. And boom. Alright, so we've got the smallest region here is a 4 by 6, which makes my initial area 24. They want to know for it to how long to for it to become 4 times its original size. So if I multiply that by 4, I get 96. So I want my new area to be 96. My initial length was 4, but it's getting bigger at 3 kilometers per second, so that's plus 3x. My 6 is getting bigger by 3x, and I want that to equal my 4 times the original area, 96. So if you type in this side for y1 and this side for y2, and you calculate the intersection, over here it would be at negative 5 seconds, which makes no sense. We throw that one out. And if I calculate this one, I get approximately 1.62 seconds. It'll be an area of 96. Okay? Alright, so how do you do, we already talked about that. I don't know why I put this here. We'll talk about that in a second. Alright, so 32. This is just some homework help. Oh, I know, that's why I put it there. We were done. I was just helping with homework. Okay. So is function composition associative? That is, does f of g of h of x equal f of g of h of x? Create an f of x, g of x, and h of x function and compute the compositions above to support your answer. So I don't know. Just make up some functions like f of x equals x plus 2. G of x equals negative 2x plus 3. And h of x equals 5x. I don't know. And then do these compositions, and then do it backwards and see if you get the same thing, and then you can tell me whether it's associative or not. Alright, so a little bit more homework help. On 32, you have this snowball problem. It says Jake stores a small cache of 4-inch diameter snowballs. This word means supply. 4-inch diameter snowballs in the basement freezer, unaware that the freezer's self-defrosting feature will cause each snowball to lose about 1 cubic inch of volume every 40 days. He remembers them a year later, call it 360 days, and goes to retrieve them. What is their diameter then? Well, first of all, okay, you have to figure out how many times does 40, because every 40 days something happens. So how many times does 40 go into 360, which would be 9 times? Okay, my formula for volume is 4/3 pi r cubed. My current volume right now, my current volume is going to be 4/3 times pi. And right now, let's see, right now my diameter is 4 inches. So at the beginning, my radius, because it's 4 pi r cubed, my radius was 2 cubed. That gives me approximately 33.5 cubic inches. Okay, so my new volume, isn't that going to be the current volume? Take away the number of times 40 days happen in 360 days, which would be 9. So that gives me a new volume of 24.5. Yeah? And then what did it say? Oh, what is their diameter then? Okay, so if I know my new volume, again, if I use my handy dandy volume function and change volume to 24.5, that has to equal 4/3 pi times whatever my radius cubed is. So if I can figure out the radius, I can figure out the diameter just by doubling it. So what I did was I divided by 4/3 pi, canceled that out, and I got r cubed equals, I typed that in a calculator and got 5.8489. So now to get r, I'm going to take the cube root of both sides, and I get r equals 1.8017. If that's my radius, then my diameter, double it, is approximately 3.6 inches. Okay? Alright, this next one, it says New Age Special Effects Incorporated prepares computer software based on specifications prepared by film directors. To simulate an approaching vehicle, they begin with a computer image of a 5x7x3 box. The program increases the dimensions at a rate of 2 centimeters per second. How long does it take for the volume of the box to be at least 5 times its initial size? So now we're talking volume of a box, which is length times width times height. And my initial is going to be 5 times 7 by 3, which is 105. And I want my new volume to be 5 times that. So multiply times 5, and I want a new volume of 2625. Okay? Now, my length was 5, but now it's increasing by 2 centimeters a second. My new width, or my width was 7, but now it's increasing by 2x. And my height was 3, but now it's increasing by 2x. So for my volume, length times width times height, I have 2625 equals 5 plus 2x times 7 plus 2x times 3 plus 2x. And if I go to my graphing calculator and I type in this for y1 and this for y2, and I calculate the intersection, it tells me approximately, oops, guess I should answer the question. It tells me approximately 4.45 seconds that volume will increase to 2625 cubic inches. Alright, we're at homework, so we are done. Happy homeworking, and I will see you next time.